Hello and welcome to the third video of the root finding method series. In this video, we'll learn about the bisection method. The bisection method is a variation of the incremental search method. If you don't know what an incremental search method is, please check the previous video in this series where we explained the method in detail. As explained before, bracketing methods start with an interval and keep reducing the size of the interval by estimating the root and then evaluating the subintervals for the sign change and repeating the process. In the bisection method, the root is estimated to be at the midpoint of the selected interval for a specific iteration. The bisection function takes the quadratic function, the start and end values of the evaluation interval, stopping criterion based on precision, and the maximum number of iterations as arguments. In our implementation, we use the incremental search, which is the ISR method here, to identify the number of roots of the function and their corresponding intervals. If the number of roots are not zero, we find the corresponding roots for each interval in the interval list. Since the stopping criterion is for the relative error between the new and the old estimate, we set the initial value of the relative error to be 100% and iteration is initialized to 0. Then the start and end point of the interval are assigned from the interval values. As a starting point, we set the starting point of the interval as our previous root estimate. We then evaluate the function at the initial estimate and also evaluate the function at the start and end point of the interval. If the function value is almost 0 and satisfy the criterion, we keep this as the root value and move on to evaluate the next interval. If not, we will continue to evaluate the interval using the bisection method. We start with a while loop which will continue to run until the relative error becomes smaller than the user-specified criterion, or if the maximum number of iterations is reached. As specified in the previous slide, we determine the next estimate by taking the midpoint of the current interval. We then evaluate the function at the midpoint and check the intervals to the left and to the right of the estimate for a sign change. If it is the left interval, we replace the endpoint of the interval with the new estimate. If it is the right interval, we replace the starting point of the interval with the new estimate. We compute the relative error and then update the iteration number. We then check if the maximum number of iterations has reached. If not, we continue and update the old estimate with x_r_new and then compute the new estimate using the midpoint formula and repeat the process. Once all the intervals are assessed, we return the total number of roots and the corresponding root values. Let's now run the bisection method on the same quadratic function that we used in the previous videos of this series, and we can see both the root values are successfully identified. In the next video, we will look at another bracketing method which is called the false position method. Thanks and see you in the next video.